plus 5r plus 6 equal to 0. Is that making sense? Just by changing y prime to r square, y prime to r, and this one to just 1. Is that clear? Alright, so from here, when you solve this, you know your calculator can do this. Abi? What will be the answer?
Minus 3 minus 2.
Eh?
Minus 3 minus 2.
Minus 2 and minus 3, Abi?
Yeah.
Okay, so that's going to give us r equal to minus 2. That's r1, Abi? R2 is equal to minus 3. Abi?
Yes, sir.
That means that what? Our general solution is going to be what? Y is equal to, what is that? What will be our general solution? C1 e raised to power minus 2x. So C1 e raised to power minus 2x plus C2 e raised to power minus 3x. Is that clear?
Yes, sir.
So, you know, this is the same thing as having C1 e raised to power minus 3 and C2 e raised to power minus 2. Abi? So that you won't do one and say you didn't state in the option. So the other is immaterial. Nobody cares about it. You can put either of them first. You can have minus 3 or minus 2 first. It doesn't matter. Alright, so that is the general solution. So if you want to find the particular solution for a given initial value problem, it means you want to evaluate the constant C1 and C2. Is that clear? So in this case, they gave us some initial values. They said that y of 0 is equal to 2 and y prime of 0 is equal to 3. What's the meaning of this? It means that when x equal to 0, y is 2. When x equal to 0, y prime is 3. Is that clear? Okay, so we have obtained our y now. So let's obtain y prime. From here, y prime is the what? Y prime is equal to, that's differentiating this. 1. So with respect to x, what would that give you? We are now. Minus 2 C1 e raised to power minus 2x and minus 3 C2 e raised to power minus 3x. So we can now substitute those values so that we can get a simultaneous equation that will help us, that will give us our values of C1 and C2. So let's do that. So when you substitute this into the expression for y, we're going to have when x equal to 0, y is equal to 2. That means 2 is equal to, we're substituting here, is equal to C1 e raised to power minus 2 into 0 plus C2 e raised to power minus 3 into 0. Does that make sense? That means that what? C1 plus C2 is equal to 2. So that's our equation 1. Is that clear? Then the next thing is to substitute for y prime into this expression for y prime. So what would that give us? That's going to give us 3 is equal to minus 2 C1 e raised to power minus 2 into 0 minus 3 C2 e raised to power minus 3 into 0. Does that make sense? So that's going to give us what? Minus 2 C1 minus 3 C2 is equal to 3. And that's giving us our equation 2. So solve the equations 1 and 2 simultaneously. What do you get?
Minus.
So calculator can also do that for you. It takes you much of the time, you can enter it in your calculator. That's if you know how to enter it in your calculator. If you don't know how to enter it in your calculator, at least you should know how to solve it manually.
Say Buhari. Say Buhari.
Say Baba.
Enough electricity to even roll body. Hey, follow blue.
Gulaba.
Enough electricity to even roll body.
No, different.
Next week, that guy will like football. He said, you know, they do all kind of 50.
Igbo, that's me.
Eh?
Who's baby?
Ah, the month. When you sabi, don't forget how to. Go work in court. Oh, Gary, no,
Mo ní gàrí lé.
no, Gary, no. Actually, Gary. Wait till though. What's for it? Gary show me.
Body shop.
Electricity.
9 and
Minus 7.
this one is 9, Abby.
Yes.
And this one is minus 7. So therefore the particular solution will be y is equal to 9 e raised to the power minus 2x minus 7 e raised to the power minus 3x. That's our particular solution for this initial value problem. This is the general solution. General solution is the one that carries the constants. Are we together?
Yes, sir.
Okay, so with that, we're good to go.
What will be the relationship between electricity and food?
Just use the internet now. So you don't know that you can use electricity to roast something.
You will next question.
Oh my God.
You don't know at this age, you don't know that you can use electricity.
We know.
What's not wrong with that?
It's wrong. But don't worry. Oh, different.
Let me tell you something. You asked me a question. Let me answer. It simply meant that his town hall meeting is different from the blabbing others do on social media. That's
the blabbing.
and he was demonstrating the blabbing. So I said that if you want to actually be serious, sorry sir.
Sorry, sir.
There's an exam going on there. It's just lower your voice. So I said that if you want to be serious, that's your next president. So when people are making, it's fine, of course, it's funny, but you should also go and look for the full video and then watch what he was communicating. At least understand what he was saying at every point. So. That's your next president now. Tinubu is your next president.
Yes.
You wear yourself. Cassava. You use cassava.
It's okay. Lower your voice. Look at number 5. I'm going to number 5 because the others are of the same category. I mean, they will give you real and distinct rules. So I want to give it another one that gives you the other category. Look at number 5. Can you solve number 5? It's quite straightforward to deal with. This is going to give us r squared plus 4r plus 4 equals 0. Do you understand what I've done here?
Yes.
When you get the characteristic equation directly. So what does this give us? When you solve it, you can do that with your calculator. R is what? Minus 2 twice. That's going to be R is equal to minus 2. That means R1 is equal to, in this case, R1 is equal to R is equal to R. You know that the quadratic equation should not give you one solution. If you have one solution, that means it's a repeated root. Does that make sense? So when you have repeated roots, we have talked about it already. That means your general solution is going to be y is equal to, in this bracket, c1x plus c2 e raised to the power rx. That's minus 2x. Does that make sense?
The answer is
This is the general solution whenever you have repeated roots. So that's about that. That's everything you need. You can see it's very simple.
Yes, sir.
Okay. And then let's look at another situation. Look at number 8. I think that should give us complex roots. To solve number 8, to solve the characteristic equation, what do you get? You can do that also with your calculator. look at it. Number 8. Y prime prime plus y prime plus y equals 0. That means you have r squared plus r plus 1 equals 0. So what does that give you?
Minus 1 over 2 plus
Okay, r is equal to minus 1 over 2 plus
root 3 over 2i.
root 3 over 2i. So you see I root 3 over 2. Then the next one will be minus, Abi?
Yes.
So it will be plus or minus this. Is that clear? That means that in this case, alpha is our real part, is minus 1 over 2, and beta is our imaginary part, is root 3 over 2. So therefore, our general solution will be what we wrote earlier, C1 sine beta x, that's root 3 over 2x, then plus, you can put all of this in brackets to avoid confusion, C2 cos beta x, that's root 3 over 2x, then we're going to have all of this multiplied by e raised to power alpha x. So this is everything here multiplied by e raised to power, what's our alpha? Minus 1 over 2x. Is that clear? You get it? Alright, so, and that is that about that. So let's solve an initial value problem that has repeated roots and another one that has complex roots. And then we close the class there. So look at number 6. It should be repeated root, an initial value problem. That means in that case we want to establish our values of C1 and C2. Okay, so as to get our particular solution. So this is the general solution for this problem. Okay. So look at number 6. So this is going to give us what? Said y prime prime minus y prime plus 0.25y equals 0. Then y of 0 equals 2. And y prime, okay, of 0 equals 1 over 3. Does that make sense?
Yes, sir.
So then we're going to get our characteristic equation to be r squared minus r plus 0.25 equals 0. You can write it as 1 over 4 and multiply 2 by 4. Anyhow you want to do it. What does that give you? The solution? 1 over 2. So r is equal to 1 over 2. So that's a repeated root. That means that the general solution will be y is equal to c1x plus c2 and e raised to power 1 over 2x. Sorry, 1 over 2x. Is that clear? So we can now find out what the particular solution will be. That means we can try to evaluate C1 and C2 given these conditions. So before we do that, we can differentiate this to obtain our y prime. Y prime will be equal to what? You know, we can differentiate what we have there, Abby. That's going to give you C1. Is that clear? And then you have this as constant. That's e raised to power 1 over 2x, 1 over 2 minus. Then plus, you know, you keep this as constant. Okay, I mean, you keep this as constant and differentiate it. That will be 1 over 2 e raised to power 1 over 2x. Is that clear? Then you have C1x plus C2. So you can tidy this up if you like, or just leave it like that. And then we're going to put in this condition. So for the first condition, they told us that y is equal to 2 when x is equal to 0. So we're going to put that here. That means we're going to have 2 is equal to C1 into 0 plus C2, all brackets, and e raised to power 1 over 2 into 0. So this is going to give us 1. This is 0. So we have only C2 left here. That means that C2 is equal to 2. You understand what I'm doing?
Yes.
That means C2 is equal to 2. So we're writing C2 like that. Does that make sense? So the next thing is to get our C1. We're going to use this y prime to get our C1. Substituting that into these expressions, we will have it to be y prime is equal to 1 over 3 when x is 0. So we're going to have this thing to be 1 over 3 is equal to, and substituting x equal to 0 here, that will be C1 e raised to power 1 over 2 is 0. And then we're going to have this to be plus 1 over 2. Okay, e raised to power 1 over 2 into 0. Then we are going to have this to be C1 into 0. Then plus C2. Our C2, we already found it to be 2. So we're just putting that here directly, 2. So at the end of the day, we're going to have 1 over 3 equal to C1. Abby? Yeah. This one is 1. If this is 1, this is 1 over 2. That's plus 1 over 2. This is 0, Abby. Then 1 over 2 multiplying 2, that's 1. That means at the end of the day, we're going to have C1 to be equal to 1 over 3, Abby, minus 1. So that's going to give us what? C1 is equal to minus 2 over 3. Therefore, our particular solution will be what? Y into C1x, that's minus 2 over 3x, plus C2, that's 2, into e raised to power 1 over 2 with x. That's our particular solution. So it's as simple as that. You just get your values of C1 and C2. So let's solve for number 9. The initial value problem that involves complex roots. So let's solve that. And go. Can I clean this? So look at number 9. You are given 16 y prime prime minus 8 y prime plus 145y. Then that this is equal to 0. And then you are given y of 0 equal to minus 2. Y prime of 0 equal to 1. Okay? So what will be our characteristic equation? 16r squared minus 8r plus 145 equals 0. So what does that give you when you solve with your calculator, please?
1 over 4 plus or minus 3i.
Eh?
1 over 4 plus 3i.
Okay, 1 over 4.
Plus 3i.
Okay, plus or minus 3i. Abi?
Yes, sir.
That means in this case our alpha is equal to 1 over 4 and our beta is equal to 3. Is that clear? So therefore our general solution will be y is equal to, put this in brackets, c1 sine beta x, that's c1 sine 3x, okay, plus c2 cos 3x, then everything here e raised to power 1 over 4x. Is that clear? That will be our general solution. To get our particular solution, we will use these conditions to evaluate C1 and C2. How did you get that? What did you get? Did you get anything different? Is that what you got? Down here, did you get anything different?
Okay, you say calculator is not.
The calculator is wrong.
Like for the complex key, it did not get 1 over 4.
What did you get?
Just sit already.
1 over 4 minus 1 over 4.
That's it. You get 10,000 over 4. Calculate it as issue.
What did you get? It doesn't even change the number, it doesn't change the sign between them. If your calculator is giving you wrong answer, you should be calculator has issues. So let's move on. So let's find out our y prime first. No, we need y prime. Look at the board, please. Look at the board. Let's finalize this. So if you want to get your y prime, again, we are going to do the same as before. Differentiate this first. You know, this is a product of two functions. Differentiate this first while keeping this as constant. So that's going to give you what? When differentiate this, we are going to have 3c1 cos 3x and minus 3c2 sine 3x. Then you have e raised to power 1 over 4x. Then plus, so differentiate this and keep this as constant. That's going to give you 1 over 4 e raised to power 1 over 4x. Then you have it into c1 sine 3x plus c2 cos 3x. Is that clear? Do you understand this?
Yeah.
Alright, so we can now go ahead and find the constant. Let's substitute for y of 0. They told us that when x equals to 0, y is equal to minus 2. So we're going to substitute that here. That means minus 2 is equal to substituting 0. That will give us c1 sine 3 into 0, okay, plus c2 cos 3 into 0. Okay, close the bracket. E raised to power 1 over 4 into 0. Is that clear? Do you understand what I'm doing here? Do you understand what I'm doing?
Yes.
Sine 0 is 0, Abby. So this one is done. Sine cos 0 is 1, Abby. So that will be C2. You know this thing is 1. Is that clear? Are we together, please?
Yes.
Okay, so that means C2 equals to minus 2. So that's that, about that. Then we'll find out using the second one now. So the second one says that y prime is 1 when x equals to 0. So I'm going to put that here. Y prime is 1 when x equals to 0. That means we have this to be 3c1 cos 3 into 0 plus, minus 3c2. We already have c2 to be minus 2. I'm going to put that directly. Sine 3 into 0. And then close the bracket. 0 is power 1 over 4 into 0. It plus, so we substitute into the next part. 1 over 4. 0 is power 1 over 4 into 0. Then close the bracket. I'm open the bracket. Then you have c1 sine the 3 into 0. Then plus c2. We already have c2 to be minus 2. Cos 3 into 0. 3 into 0 plus 3 into 0. Then we'll close this bracket. So we can simplify this further. This is going to give us 1 equal to 3c1 plus 0. That's 1. So what we have here is 3c1. I mean 3c1. This thing is going to give us 0. Sine 0 is 0. So all of this is gone. This is 1. So what we have from this first part is 3c1. Then from the second part, you have plus 1 over 4. Because this is going to give you 1. Then into what of this? Keep quiet. Then go. This is going to be minus 2, Abby. Minus 2. Is that clear?
Yes, sir.
Because this one is 0. This is minus 2 times 1. That's minus 2. So from here you can get your C1. This one we cancel this. You have 1 over 2. Okay, so from here you can get your expression for C1. I'm going to have 3C1 is equal to 1 minus. This is minus already. That will be plus 1 over 2. Is that clear? That means 3C1 is equal to 3 over 2. That means C1 is equal to 1 over 2. Is that clear? And that completes our solution. So we can write the particular solution for the initial value problem now, knowing the value of C1 or the values of C1 and C2. Therefore, particular solution will be y is equal to C1, that's 1 over 2 into sine 3x plus C2. Our C2 is what? Minus 2. This is going to be minus 2 cos 3x. Then everything here multiplied by e to the power 1 over 4x. So that is that about that. Ladies and gentlemen, that's the end of today's class. I'll see you in the next class. Move on to the next topic and we'll have a short test before we start the next class. Thank you for coming.
Lose volume.